Math 1314, section C87. Homework 9, linear equations in two variables, linear functions. Video 3, calculating slope. Questions 5 through 12. Many of you are already familiar with the concept of slope, but I'm going to take it from the very beginning in case you've forgotten about it or if you're not familiar with it. So let's start with slope. What slope is. Slope is a measurement of the steepness of a line. That's all it is. You ask a lot of people what they know about slope, they say lots of things, but they rarely say this. So first and foremost, it's important to understand that when you are calculating a slope, you are calculating the steepness of a line, how steep a line is. Now, there's a few things we should talk about slope before we get to formulas and everything. Number one is if the slope, let's try it this way. A line has a positive slope if and only if the graph is increasing from left to right. Translation. If you have a line and it is going up as you move from left to right, then this has a positive slope. And vice versa. A line has a negative slope if and only if the graph is decreasing from left to right. In other words, as you move from left to right, the graph is going down. So if I were to draw another line and I wanted to draw one with a negative slope, it would just have to move downward as we move from left to right. So the sign of the slope, positive or negative, indicates whether your graph is going up from left to right or whether your graph is going down from left to right. And it is important to say from left to right, because if we went backwards, we would be going the opposite directions. In other words, if we went right to left, this line would be going down, but it still has a positive slope. So whenever you talk about the sign of a slope being positive or negative, you're talking about whether the slope is in the line's going up or going down. And again, that may have been backwards to you. Where the line is going down, up or down, as you move from left to right. All right, so what else do we need to know about slope? Well, what if your slope is 0? What would you think that would mean? If slope is attempting to measure steepness and you say the steepness is 0, well, what would a line look like if it had no steepness at all? It would look like that. So number 3, a line has a 0 slope if and only if the line is vertical. Excuse me, not vertical, horizontal. So the only way a line can have a slope of 0 is if it's a horizontal line. Because if we're attempting to measure steepness, a line with no steepness is a horizontal line. It does raise the question about what happens if the line is vertical. If you're attempting to measure how steep something is, if it goes straight up, well, we can't assign a single value to it, because if we do, then we're measuring a certain steepness, but that could be higher. So in other words, and it kind of makes sense if we're measuring steepness, then the steeper the line, the greater the slope should be. So if I were to raise a line higher and higher, I would expect the slope to get higher and higher. If I give a number slope for a vertical line, like let's say the slope of a vertical line is 1,000,000. Okay, then what would a line of slope 1,000,001 look like? You can't get any steeper than that. So we really can't assign a value to the slope of a vertical line. So what does that mean? That means it has an undefined slope. A line has an undefined slope. Now, this is different than saying the slope is 0. 0 is a number. It's measuring how steep a horizontal line is. To say it has an undefined slope means that we can't give it a slope. A line has an undefined slope if and only if the line is vertical. So vertical line, undefined slope or no slope. Horizontal line, it has a slope, its slope is 0. And just to draw a picture of it, since we drew pictures of the rest of them, there's the X and Y axis. and here's a little vertical line. All right, so those are some of the things I wanted to get out of the way before we do anything with formulas. Slope is a measurement of the steepness of a line. A line increasing from left to right has a positive slope. A line decreasing from left to right has a negative slope. A horizontal line has a zero slope, and a vertical line has an undefined slope. All right, but none of this tells us how to actually measure slope. So how do you measure slope? A lot of you know this already. Slope equals, and I'm going to set up a separate text box for this because I want to draw a fraction bar. Rise over run. Give me 1 second to draw a fraction bar. Slope is a comparison of rise over run. Now, what do I mean by rise over run? Well, what I mean by rise over run is if you have 1 point and another point on a line and you want to measure steepness, the run is how far you have to go horizontally. It's the horizontal displacement, if you will. And the rise is how far you have to go vertically. It's the vertical displacement, if you will, to get from point A to point B, from the beginning to the end. It is worth pointing out that if you run to the right, it's a positive run, but if you run to the left, it's a negative run. That makes sense because when we go to the right, when we're plotting points, that's a positive value. And when we go to the left, plotting points, that's a negative value. The same thing with the rise. A positive rise is negative. If you go up, it's negative. If you go down, though, a downward rise is a negative rise, if you will. So if we can calculate how far we have to travel horizontally and then vertically to get from one point to another, then the comparison of those two values, rise over run, is going to be our definition of slope. And this definition is consistent with all the things that we said about slope a minute ago. If our line is going up from left to right, then both the rise and run are positive, and so the slope would be positive. But if our line was going down from left to right, in other words, if we had a line that looked like this, and we picked a couple of points on it, and we did the run and the rise, because we're going down, the rise would be negative, the run would still be positive since we're moving left to right. So we would have a negative over a positive, which is a negative. And so the slope would be negative. It's even consistent with horizontal and vertical lines, because if we had a horizontal line, we'll draw that in pink, and we try to get from point A to point B, we would have some sort of run, but the rise would equal 0 because we're not going up or down. So that means we would have 0 on top of the fraction, some other number on the bottom, and therefore the fraction would be 0. And it's consistent with the slope of a vertical line being undefined. If we pick a couple of points on a vertical line and we try to rise and run, we would only rise, but the run would equal 0 because we wouldn't go left to right to get from the first point to the second point. Well, if the run is 0, that means the bottom of the fraction is 0, which means the fraction is undefined. So everything we wanted to be true about slope is still true if we measure it as rise over run. All right, well, that's cute and all, but how do we actually figure out this rise and run? And the answer in a word is to subtract. So let's take a look at a specific example, and this will turn it into a formula, if you will. Let's say we have the point 2, 1, and we connect it to the point 6, 4. And we want to know what the slope of this line is. Well, we know slope is rise over run. So all we have to do now is figure out how far do we run and how far do we rise. Now, we could just count, but sometimes we won't have the picture, and sometimes the numbers won't be easy to count with, like if they're decimals. So let's think about this in terms of x's and y's. The x of the first point is 2, and the x of the second point is 6. So asking how far we run is just asking how far apart those two numbers are, but that would just be their difference, the second one minus the first. This is a run of 4. You can see it because there's 4 spaces here. And we could do the same thing for the rise. We would just have to focus on the y's. We rose from a y value of 1 to a y value of 4. So to figure out how far we rise, we just do the second y minus the first y and get 3, which you can see here because there are 3 spaces going from 1 to 4. Well, if we know that the run is 4 and the rise is 3, then we have everything we need to calculate the slope of the line. The slope of the line would be 3 over 4. rise over run. But we don't have to draw a picture and check off spaces and make sure they're right and everything. So we need a more systematic way to calculate slope. Well, look at what we did to get to the 3 and the 4. To get the 4, the run, we subtracted the x's. And to get the rise, the 3, we subtracted the y's. And we can do that every single time. So we'll say it like this. If a line passes through 2 points, and we need to write their coordinates, but we need to write them generically. So we're going to call the first point x1, y1 and x2, y2. Now, normally when I write this, I would be writing subscripts. So in other words, I would normally be writing x subscripted with the 1, y subscripted with the 1, and x subscripted with the 2, and y subscripted with the 2. But since I can't type subscripts in the word processor in Zoom, the best I can do is just write x1 and y1, x2 and y2. But let's start with if a line passes through 2 points, x1, y1, and x2, y2. Then the run is equal to the second x minus the first x. The rise is equal to the second y minus the first y. Just remember, to find the rise, subtract the y's. That rhymes. To find the rise, subtract the y's. And then the other one is the x's. The run is the difference in the x's. The rise is the difference in the y's. And the slope is. All right, now's the time to introduce a letter. Well, it's a letter you've already seen before. It's the letter M. But for whatever reason, there's some theories as to why. The variable for slope is M. And so our formula is M equals the rise, which is y2 minus y1, over the run, which is x2 minus x1. This is our formula for slope. If you're given 2 ordered pairs, think of it as a recipe. Take one ordered pair, take another ordered pair, bake at 350 for 20 minutes, ding, you got a slope. All right, let's take a look at some homework questions. Excuse me. Find the average slope of the hill. Write your answer in exact simplified form. Now notice we're not on a graph. We're not given any x's and y's, but we are told to get from the bottom of the hill to the top of the hill in terms of horizontal and vertical displacement. We have to travel 730 feet to the right, so that's a run, and 268 feet up, that's a rise. Well, if we want to slope, it's just rise over run, 268 over 730. Now, it won't accept this. It might actually count it wrong the first time. Nope, it'll say write your answer in simplest form. So you would have to reduce it. I'm going to kind of reduce it here. These are both even. I know I can reduce this by 2. 268 divided by 2 is 134. And if I reduce 730 by 2, that's going to be 365. I'm not sure if that will reduce any further. It will not. Whew. Didn't want to squander all my opportunities. But most of the slope problems will be of this form. Here's 2 points, find the slope. Now, you can actually do the work in the homework. I would recommend writing it out because on paper, because you're practicing for your test. But on the top, it's the rise, which is this difference in the y's. So it's the second y minus the first y. And in the bottom, it's the run, which is the difference in the x's, the second x, which is 4, minus the first x, which is 8. Now, it's not going to accept this answer because I have to work out both of these, but I wanted to show you how to set it up. The most common mistake people make is putting the numbers in the wrong place. Be crazy deliberate about it. What am I putting here? Second y. Who's the second y? -1. And at some point, it becomes a little bit smoother to go. Let's answer the top and bottom. -1 minus 6 is -7. I thought that would replace -7. 4 minus 8 is -4. That fraction should not be accepted because it's not simplified completely, because negative divided by negative is positive. So we can cancel those negatives. That should be correct. Thank you. And the same with the rest of them. 7. This is the one I said you could skip because it has decimals. And the only reason I want you to skip it is that when you actually do the math, you get one decimal on top of another, and then it asks you to clean that up. And that's a skill that I'm not focusing on right now. So you can skip this question. I will reimburse you points for it once the due date passes. 8, same song and dance. And it doesn't take too long for these guys to get a little bit out of control. Notice it says select undefined if applicable. Gee, I wonder what's going to happen here. If we set this up as the second y, so negative 9, minus the first y, so minus 8, and on the bottom, the second x, 2, minus the first x, 2, you notice the bottom is going to equal 0. And the top is going to equal negative 17. Not that it's really going to matter. You can't have 0 on the bottom of a fraction. This fraction is undefined. And so the slope is also undefined. Now, what type of line is it if the slope is undefined? Vertical. Okay, number 9 is kind of the same thing. That one's going to be not undefined. It'll be a different scenario. Number 10. All right, on number 10, this is one where we're given a picture, and we got a couple of ways that we can do it. We can either locate a couple of points whose coordinates are clear and then do the rise over run, or label the points coordinates and use the formula. In this one, you're looking for a point that goes through the intersection of a horizontal and vertical line. Here's one right here at -3, -3. Here's another one at 1, 0. There's a third one way up here at what seems to be 5, 3, but pick 2 points and either draw the rise and run or label their coordinates and use the slope formula. And I believe that's the same thing for 11 and 12. Oh, 12 is a vertical line. I know what its slope is already. And that's the end of the video on slope.